So this now we'll see the descriptive analysis. So this descriptive is regarding, we have talked regarding this descriptive in several of our sessions. This is a relatively easy session, but the only thing is how you have to proceed, that is important. So once you have your clean data, now you want to add this descriptive statistics. So what is this descriptive statistics? Basically, in descriptive statistics, we basically summarize the data and we organize the data. So this descriptive statistically basically means that we summarize, organize, and simplify the data. Now, this is one question for you. If you have to make a frequency table, for which variable in this case you can make frequency table? Please write yes and no. Gender, okay. Smoking status, gender. AC. A and C means age and BMI, smoking. So anyone, yes. So yes, it can be made for all variable. Even for age, like it is not clear here. If you have a age category, then you can categorize the age and you can categorize the BMI like we did in that computation. You can recode it and you can have a frequency table. So in this case, again, mean or median can be calculated for which variable here. Now you have to write answer. So first option is age, then second is gender, third is BMI score, smoking status, and all. So mean and median, is it possible for all or is it possible for some variable? Few variables which are there in front of your screen. So no gender, yes, good, because gender is a categorical variable. Although it has got 1 and 2 in the background. So if you press mean, it will give you some value, but it has got no meaning of it. Because a categorical value, although with that number 1 and 2 and 3, it might give you some mean, but it has got no meaning. So we can calculate mean and median for age and for BMI score, because these are the only two values or the variable which are on scale measurement, right? So descriptive statistics, we call it as a summary statistics. Basically, we use it to describe or summarize the data, which tells the meaning of the data per se. And there are basically two types of measurement which we do in the descriptive statistics. There is a measurement for central tendency and there is a measurement for spread. We'll see what we use to measure the central tendency and what we use to measure the spread. So the advantage with descriptive statistics is it has got no uncertainty, because with this descriptive, you are not projecting the population standards or population parameter. So that's why this descriptive has got no uncertainty. Now, the limitation of this descriptive statistics is that you are telling the summation of only those people which you have used for your sample. That means your results can be extrapolated only on the samples which you have taken. Otherwise, if you want to extrapolate, or the external generalizability of the result will not be there for the population or for the projected population. So descriptive statistics is basically we describe about the sample, but we don't try to infer about the population because we are not projecting any population parameter, and we don't do any hypothesis testing in descriptive statistics. Whereas if you see the inferential statistics, in this case, we infer about the population. So we do make some external generalization of the data and about the population. We do the hypothesis testing as well, because we form the null hypothesis, then we have an alternate hypothesis, and then we either accept the null hypothesis or we do not accept or reject the null hypothesis. Similarly, the strength of this inferential statistics is that here the population parameters or population values can be estimated, and the limitation is that there is always a element of uncertainty, because you always describe this inferential statistics with confidence interval. So you give a range of values of that population parameter. That's why it is uncertain, or there is an element of uncertainty which exists with this inferential statistics, which is not the case with the descriptive statistics. So inferential statistics is basically we describe about the data, we try to infer about the population, and we do hypothesis testing. So descriptive statistics is, like we said, it's for this, we calculate the frequency distribution, which is in the form of a frequency table. We do take the central tendency, which is in the form of mean, median, and mode. And then we describe about the variability, which is a standard deviation, variance, etc. So if we talk about this frequency distribution, there are frequency distribution tables. So in that case, there is a group frequency because we have the group frequency table, which we will see, and we use some class interval. Like in case of age, you may have a class interval, like fixed interval, 5 years or 10 years, or you may have some cutoff, which is based on some biological criteria. Like you do take the adolescent, like early, mid, and late adolescent. So if already there is some criteria which is existing for this age or any other variable, that class interval, then you should use that class interval. Otherwise, you should have a same intervals if you are using a arbitrary or hypothetical interval. In that case, you should have a same class interval. In the case of frequency distribution, you have got the histogram, you've got the bar diagram, and you have got the pie chart. Again, in this case, in frequency distribution, you have got the quartile, quintile, and decile. So when you divide your data into 4 parts, we call it as a quartile. When you divide your data into the 5 parts, like 20th, 40th, 60th, 80th, and 100th, then it is known as the quintile. Or when you divide your data in each 10 equal part, it is known as the decile. So now there are some measures of central tendency. Mean, which is a very common measure of central tendency, and it is usually used when the data is normally distributed. And when the data is skewed, whether it is a left skew or a right skew, since the median is not sensitive for the extreme measure, so we use the median. So mean is a very sensitive measure and it gets deviated if there are extreme values. So in case of a skewed data, we use median and interquartile range instead of mean. And then there is a mode. So mode is, which is the greatest frequency, the data, the number which is appearing more number of times, that is known as the mode. So in this example, you can see that this is a data of 10 people, which has got a value of like individual 200, 145, 220, 225, 180, etc. So these are the values. And then if you take out the mean of these values, it is approximately 186.6. I have calculated it and I have written it. You don't need it to do it because the software does it for you. And the mode in this case, since it is appearing 220 is appearing twice, so the mode is 220 in this case. And in the other case, towards the right side, with the data is there. If you see the median, so this in the first case, you will see that the data is not that much. The range, if you see, it is from 145 to 220. And in this case, if you see the median, so median is if the data set is like 10 in number, in this case, it is 10. So you will take the median 2 values, which is the 5th and 6th, and you take the mean of this. So 180 plus 220 by 2, that is the mean. Because here I have arranged the data in the ascending order. Here the data is not in any order. So for the calculation of mean, you don't need to arrange the data. But for the calculation of median, you need to arrange the data in either ascending or descending order. And that's what has been done here. This is the same. These two are the same data set. The only difference is this is in the ascending order. So this is the median. And in case of an odd number, you will take the mid value, which is the median. So normal distribution, if we talk about the normal distribution, in this case, the mean, median, and mode coincide. And the mean is the most sensitive measure if the data is normally distributed, mean and standard deviation. So in case of a normal distribution, you can use both mean and median because then both will be nearly same. In case of a skewed distribution, this mean and median differs. So this is one graph where you can see that this is a skewed distribution and the skew this is the tail. So you can, if the tail is going towards the right side, the data is skewed towards the right side. So by the direction of its tail, you tell about whether the data is right skew or left skew. In this case, you can see that the median is more than this mean is more than the median because median is sensitive towards the extreme values. That's why this median is more in this case. So if the data is skewed in nature, in that case, the preferred measure of central tendency is the median in interquartile range, because in this case, the mean is dragged towards the direction of skew. And in this case, you can see that the mean is dragged towards the right side because it's a right skew. And median, since it is not affected by the extreme values, that's why here we will use the median. So depending on the type of variable, if it is a nominal variable, so the best measure of central tendency is the mode. If it is an ordinal variable, it is the median. And if it is an interval and ratio, which is not skewed, then we describe it as median. And if it is an interval and ratio scale, which is a skewed one, then we use median to as a measure of central tendency. Now about the spread. So spread or variability, there are few measures of the spread. The first is the range. So you describe the minimum and maximum, and then you explain about the range. Then second is your standard deviation or variance. So we'll see what is the standard deviation. When you square the standard deviation, it is the variance for a population, and then the standard deviation and variance for a sample. So for this case, in this case, you can see there are 10 data set. And you can see how we calculate the standard deviation. We are showing you just for understanding, so that when you read this standard deviation, standard error, that thing, this background information should run into your mind. Otherwise, you don't need to calculate any of these. You don't need to calculate this manually. It is just by a single command that you get all these values. So just for understanding, we have shown it with the help of this 10 data. So this is like cholesterol values. And if I have to calculate the standard deviation of this, you can see that I will take out the difference between the mean from the mean. So the mean was 186.6, which we calculated from the previous data. And this measures the individual value minus mean. So you can see this minus and plus sign depending on the individual value. This was largest or the mean was largest. But this sign doesn't make any difference, because you ultimately what you do, you make the square of this value. So this is the square of these values. So you make the square of these values, and then what you do, this variance is defined as the sum of squares divided by total sample minus 1. And this concept of variance, we will read this in the independent sample t-test and ANOVA also, because there we understand regarding the between group variance, within group variance, etc., test of homogeneity. So these concepts, once again, we will touch when we'll come to those tests. Right now, you understand that this variance is defined as sum of squares divided by total number of samples minus 1. So sum of square is basically this. This square, you add it, and this will be the sum of square divided by total sample minus 1. In this case, it will be 9. So this will be the 9542.4 divided by 9. So in this case, the variance will be 1060.267. And standard deviation is under root of this. In this case, it is 32.56. So when standard deviation and variance, you should think that it is a data set and that background calculation is going behind. And if you have to calculate the standard error, basically the formula is, in the numerator, you take the standard deviation, and in denominator, you make this under root of n. That gives you the standard error. And then you calculate the confidence interval, that is the mean plus minus 2 standard error, which gives you the population estimate or the population parameter. So in this case, the standard error would be 10.30, because the sample size was 10. And by this, you know that the standard deviation is 32.56. So the standard error will be the 32.56 divided by 3.16. It will be 10.30. So this was regarding the statistics, descriptive statistics. So now showing it to your data set. So I'll show you the questions which I need to read. So this is my demo sheet for the descriptive and correlation. So I have to make an overall frequency table of gender, age group, smoking status, socioeconomic status, comorbidities group, and admission. Okay. So I'll show you. I have just closed this because now I have a clean data sheet for the demo where I have So this is for the demo of descriptive statistics. This is my data sheet, Jamovi data sheet, where I have coded the variables, and this is the full variable which we took. Like in this case, you will see all the continuous variable like ferritin and hemoglobin, maybe TLC, and a lot of continuous variable, which was not there in the previous sheet because that we have created only for the demonstration purpose. In this case, you can see like what I told you, if you have to see only the data set. So you can see there are a lot of data which has been populated here. Since this correlation is already coming, so I will go to this analyze. So this is the first, let me describe the data set. So if you want to see the full data, I have what I showed you, that go to this data, click this data, and I want this full view, not this view. So I will click this. So now I've clicked this, so I can see the whole data set in one view. So you can go here and you can see that this is the gender, age, socioeconomic status, then all those comorbidity, yes and no. And then this is the total number of comorbidities. And then this is the maybe the BMI score, systolic blood pressure, diastolic blood pressure, SpO2, etc. And this is the cortisol. So similarly, all these continuous variable is there. Again, I'll go to this view and I want to have both these two views. So the first task is to do a descriptive statistics of in form of a frequency table. So what we'll do, we'll go to this analyze. In analyze, you can see there are many options. There is a exploration, there is an option of t-test, then there is an option of ANOVA, regression, frequencies, factor, survival, because we have added this module. Once you add more module, you can have more options appearing here. Since I have not added many modules, so these options are not appearing. So I will go to this exploration, because in this exploration, you have the option of descriptive as well as charts. So in this there's a scatter plot and there is a Pareto chart. So scatter plot we use. Pareto chart is generally used for marketing research. In health, we don't use, we very less use this Pareto chart. So we use basically the scatter plot, and we'll see when we use this. So go to descriptive. So once you click this, there is a appearance of this windows there. I may delete this. So it has started. So since you will see already these values are there, but I want only, so I will go here. You can see in this, there is a variable list, and then there is a variable, and then there is a grouping variable also. In this case, can you see this descriptive? If you click this, you can see there is this is like the appearance of the table. You want variable across row or you want variable across column. This we'll see once we have the result populated. So now this is already appearing, but I don't want it. So by default, this is clicked. So I will uncheck this. So I have unchecked all this. In this sample size and missing, you should keep this because this tells you regarding the number of samples and the missing data. And then I have again this unchecked, this standard deviation dispersion. So you can see now I have in this descriptive, this missing and n. So now I will start shifting the variable. So frequency table you have to make for all the categorical variable. So in this case, like I will use this option of maybe this shift, and then if you go and go to the last thing, so maybe till CKD, all got selected. So you can move this, and then again, if you want to know regarding the total number of comorbidity, this one. So this also goes, so it has gone by mistake here. So I have to move this to this table. And then you may take gender, but gender maybe I have deliberately kept because I wanted to show it across that grouping variable. But you may take gender also as this frequency table. So it takes some time. And then I will click this frequency table. So once I click this frequency table, you can see the appearance of all the tables. And in this case, right now, the view is variable across column. So you can see the low, medium, and high, like socioeconomic status. This is the total percentage. This is the cumulative percentage, like we see in the SPSS. So all these results, this have appeared here. And then if you want to change it, like if I want this across any, but if you want to be like this, then first you save this data, because once you change this, maybe if I have changed this to, if I want a standard deviation and mean and mode of these continuous variable, this will disappear. Like I'll show you. Maybe I want now mean of all these. So for that, I need to transfer all these variable here. So once you transfer this back, this whole output will be empty. There is nothing here. And now if you want to calculate the, maybe the mean, median, and mode, so this maybe I will shift here and I will uncheck this, and then maybe I can go to for the calculation of mean and median, etc. So here you can see, but that frequency table, that has disappeared. So this has got one active sheet always, which gives you the result of the actions which you are performing towards the left side. But if you want your result to be saved, then you should have a copy of it. Like I'll show you. Maybe I can delete this. And again, I'll show you how to do that. So if I want the frequency table, I'll go to this Explore, Descriptive, and then maybe I will select all this. By selecting, you click this first and then come to the last, and by pressing this shift, all will be selected. So press this, I have moved this back again. I have unchecked this mean and median because I don't want mean and median now. Since the result or the interface is dynamic in nature, if you uncheck this, it will disappear. If you click this, this will appear. So again, I'll show you what you should be doing. Like in this case, maybe with the gender, I have shifted the gender here and I have shifted all other variables also. So maybe I have pressed the shift button and I'll go to the CKD, and then I want to shift this also. And I have shifted this and I have clicked this frequency table. So now I want this to be preserved here. And if you want to write the interpretation, so if you click this, because I said that this is again like a Word document, so you can keep writing here. So you can write your interpretation and then you can import this in the copy paste it in the Word. We'll show you. So like I can write here, the result is showing that the males outnumbered female, because the males outnumbered females. And then you can show the percentages in the bracket, like 72.2% versus maybe 27.8%. So 27.8%. So this was, this is how in the, no, just below this table, you can keep on writing the interpretation of this frequency table. And once you are done with this, right click this and go to this analysis. Can you see there is an option of analysis? In this analysis, press this option of duplicate. So once you have pressed this option of duplicate, this result will be there as an inactive sheet in your output. And now this active sheet is also there. So now whatever you will do, this will appear here. So once I have done, maybe like I want it across a group, maybe like across this outcome status. Maybe outcome I have moved here. Just a sec, let me check with this. So this was the outcome. Maybe outcome is basically death or discharge. So if I want this frequency table across this outcome, then I may split this, and then you can see here, it will show you the male and female, and then it will show you the across the discharge and death. If you want the percentage, You can change the view also. You can show it like this. So it may come like this. Total number, percentages. I cannot see option. Let me see. That will go in this frequency, so that we can see later. So this view you can change across the column and across the group. And then you can also save this, because I want it across the table also. So you can again go, and I will select all this sheet. So right click this, and again this you make a duplicate. So now the third sheet will be active. In this third sheet, now I want because the next question to me is maybe I have to compute the mean and standard deviation and median. So this is the next. This is the dummy table which we made initially. Just this is the template which we will we will provide to you. So maybe this is the dummy table, and you can populate this with the result which you have seen there, write the interpretation, or you can import that whole sheet and then you keep it as such. This is like, again, frequency table across this outcome which we have seen.